we're now going to do lesson 3.2. Now remember we said that the entire chapter of 3.1 is about linear equations and inequalities. Alright? Lesson 3.2 is going to be about solving equations using tables and graphs. Okay, 3.1. Just to reiterate what happened in the last lesson, was talk about constant increase, which you can see in an equation, or in a table, or in a graph, and constant decrease, which also you can see in an equation, a table, or a graph. Okay. 3.2 is going to be solving these equations using a table or a graph. Okay? So first they're going to solve using one of those two things, table or graph, and then they're going to talk about situations that lead to equations. Okay, what kind of situations will lend themselves to being set up as an equation? So the big idea is that tables and graphs lead to exact or approximate solutions to equations. Alrighty. Now, there's only one vocabulary, it's actually a vocabulary phrase, and it's solution to an equation. A solution to an equation is the value of the variable that makes the equation true. So in a very simple way, if you had this equation, 2 plus x equals 6, okay, obviously the solution is 4. So the solution to that equation would be the value of the variable that makes it true is 4. And a very, very simple one. Alright, the homework is to read 3.2. Do not just listen to the video and jump right into doing the homework. Read 3.2 and then do 1 through 23 odd. Alrighty, 3.2, solving with a table and graph. First of all, let's see. Now we're back to Miss Lovett and these Twizzlers, okay? So Miss Lovett has these Twizzlers, and remember she said, hey, how long will it be before I get to 100 Twizzlers in my packages Twizzlers in my pool? Well, we said, okay, that would be 100 Twizzlers. She started out with 10. She added 3 per day, okay? Now, how many would it take before I got to 100 packages? The last time we talked about these 100 packages, we were saying she had 1,095, and she was eating 2 packages a day, and she was getting down and down and down. And the question was, when would she get to 100? Okay? This time what we're saying is she's starting at down here with 10, and she's adding 3 and 3 and 3. Uh-oh, I made a mistake. Sorry about that. Those shouldn't be connected. 3 and 3 and 3 and 3 and 3. The question is, when will she get up to 100? Alrighty, so that is start with 10, adding 3 each day. When will I get to 100? Let's solve this using a table. Okay? So, you can use your graphing calculator to create this table. Go into your graphing calculator, and instead of entering 100 equals 10 plus 3d, at y1, enter y equals 10 plus 3x. Okay? Then your graphing calculator can let you create this table, all right, and see when you get a solution for y of 100. Okay? So I enter this into my graphing calculator, and I go scrolling through that table in my graphing calculator, and until I get to, yay! I've got, this is my x in my graphing calculator, and this is my y, okay? I've got 100. When I get to y equals 100, my x is 30. So the solution to that equation using my graphing calculator is x equals 30. So you don't even have to actually do the math computation if you know how to use your graphing calculator properly. Use your graphing calculator to help you, okay? All right, so in this situation, again, you replace the 100 with the y, type the rest of it in, scroll down till you get to 100, and that's, yay, 30 days, yay. All right. Now, what if you want to use a graph to solve this? Okay, then Miss Lowe's like, I like graphs. They're pretty. Okay? I have this equation saying, started out with 10, added 3 every day. When will I get to 100? And I want to use a pretty little graph to figure this out. Okay? So once again, in the graphing calculator, change this equation to that equation. Instead of 100 equals 10 plus 3d, y equals 10 plus 3x. Go to the graph part of your calculator and look at it, and you'll see, this should say table. This should not say table there. That should say graph. Sorry about that. Look in the table. Look in the graph. Look in the graph to see what value of x gives a value of 100 for y. So you're like, you're looking at your graph in your graphing calculator, and you go along until and there's going to be dots. Now on your graphing calculator, they're going to be connected because your graphing calculator assumes you mean all the points to be connected. We know those points aren't actually being connected because she's not putting them in a Twizzler at a time. Okay? But it will look like this on your graphing calculator. Okay? But anyways, you go across until you get up to the y of 100, and you go, what's that on my x? You could actually, if you wanted, go over here on your graph, okay, and then, trace up and down until you get to 100, and then using your trace function, realize that's a 30, okay? All right, now that's not as clear on here as it could be because I'm not showing you a graphing calculator, but hopefully that makes sense to you. Type this into y1 equals, okay? Make a graph. When you get the graph on your graphing calculator, just trace along it until you get to the y. Okay, you know how it shows you down here y equals, and it'll show you like 100 point, let's say 13. That's darn close. And it'll say at 100.13 x equals, and it'll give you a number, something a little bit greater than 30. Let's say 30 point, I don't know, 1. Okay, and you're like, yeah, I get it. If I trace, it's about 30. Now remember, once you get an x, once you get an actual x, you could say, you know what, I'm guessing it's 30. And with this 30, then you could use your calc button and see, I'm guessing it's 30. Does that give me 100? And once you use your calc button, it will actually calculate it for you and figure out, yeah, sure enough, it's 100. Okay. Now, the last thing they talk about in this lesson 3.2 is situations that lead to equations. Before we do that, though, let's go back. You don't actually, obviously, have to use your graphing calculator to do this. You could do this one by hand because it's so simple. But anyways, situations leading to equations. All right? So, basically, there's some situations that lead to equations really nicely. Okay? So, how you do this is figuring out what things are changing and what things aren't changing in the graph, okay? And whether or not it's increasing or decreasing. So here's that one where we said Miss Lovett starts out with 10, she adds 3 a day, and she gets 100. Now that's the equation we came up with, but how did we come up with that? Well, the thing that's not changing, not varying, is called the constant. Okay, cool. See, it's right there, all by its little lonesome. Okay, the thing that is varying is the variable. That's D. And how much it is varying by is the coefficient of the variable. And we had this word coefficient before, okay? The number in front of the variable is called the coefficient, and it's how much the variable is varying by, okay? And then the last thing you got to figure out is, do I have something that's increasing or not? Okay, so similarly on the decreasing, you say, what is my constant? Now this jumps back to that problem we had in 3.1 where we said Miss Lovett had 1,095 packages of Twizzlers in the pool, okay, because she'd saved them for a year. And so that's the thing that is not varying, the constant. Okay, what is it that's varying? Hey, days are varying. Someday it's going to be more and more and more days. So D is my variable, okay, because it's the thing that's varying, the variable. How much is it varying by? Okay, That's the coefficient. How much it's varying by is the coefficient. And we said in the last 3-1 that it was going to go down by 2 a day. She's only eating only two packages a day. Okay? And then you decide, okay, what's happening here? Is it increasing or decreasing? It's decreasing, so obviously that's a constant decrease. And that's as straightforward as it is to set them up. What am I starting with? Okay, or what's the thing that's not varying, I should say? What's the thing that's not varying? Okay, that's the constant. What's the thing that's going to vary? And that could be days or weeks or months or whatever. How is it varying? Well, it's changing by 3 a day, or it's changing by 2 a day, or whatever. And then what's happening? Is it going up, or is it going down? And that's pretty much it for 3-2.